Does Excel have three-dimensional graphs or charts? The answer is yes and no. Let's see which options you have. In this case, we don't have a 3D graph. It's two-dimensional. An x-axis of values and a y-axis of values. But in this case, I added a secondary y-axis because column B and column C has values of a very different magnitude. If we didn't make this a secondary axis, we would get a very weird chart. So I'm going to right click on that series of values, format the data series, and I had chosen here a secondary axis. If I had not done that, it would look like this, which is very uninformative. So I'm going to set it back to a secondary axis. Again, this is not three-dimensional, but it looks a little bit like. This is a three-dimensional one, but it is not three-dimensional when you look at the axes, because two axes are categories. So can you have values here and can you have values there? Yes, you can, but let's see what the limitations are. This is a 3D one. You can change the looks of it. So if I go here and I do a 3D rotation, I can change the way you look at it. Sometimes you want it to be a little more this way, so you can see all the stacks better. Maybe you want to look more from the top, etc. But again, it's not a real 3D chart. This one is also a fake one. It has vertical values on the axis. It has also values on the horizontal axis, but let that not fool you, because these values are really categories. That means it cannot plot anything between 50 and 60. And another condition usually is that the intervals in here are equal. Otherwise you get a fake impression. In this case, I try to make the other axis also numeric. In this case, time values, it's numeric, but again, the same story. They are categories and not real values. So it cannot show you anything between noon and 5 o'clock in the evening. Is it three-dimensional? No, but it looks it. But it's a fake one. The same story here again. We have real values here, but with equal intervals, so they are equidistant. And here again values. This is the student's t-test. These are the t-values. Those are the degrees of freedom. So in this case that would be a sample with size 14. Degrees of freedom is the size of the sample minus 1. And I plotted that in this kind of chart. If you want to know what kind of chart that is, I'm going to the change chart type version. It is what they call a 3D surface chart. You can choose this one, you can do that one, and it's by definition three-dimensional. But I told you already, this is what it would look like if you did it that way. Sometimes that is not very informative, so I'm setting it back to the old version. And it shows you that at small sample sizes, the inclination is a little steeper than normal. But again, these are categories. These are real values. So a similar story if you want to put a formula in here. I put the formula in here. Half times 1 plus cosine of the square root a2 to the power of 2 plus b1 to the power of 2, and I made some of those locked or absolute, so I can copy that formula downwards and copy it to the right. It gives you part of the so-called Mexican head. I repeat my story again. This is the only value axis. These are categories. It looks pretty good though. If you want to see the full Mexican head, then you have to go from -10 to +10, -10 to +10, and this is the full one. What kind of chart is this? It is again a 3D surface chart. So you can do some good things with 3D surface charts, but it's not a real three-dimensional chart. Is there anything in Excel that comes closer to a real 3D? Yes, but it looks a little primitive. It's called a so-called bubbles chart. It has real values on the horizontal axis, real values on the vertical axis, but the third axis is done with bubbles. The size of the bubbles tells you what the value is of those elements. So how do you get it? If I go to the chart type, select data, here are the data. It has a series name, I skipped that one. Then it takes the X values, A2 through A18. It took the Y values from B2 through B18. And the Z values, or whatever you want to call it, C2 through C18. That is the bubble size. That is the closest you can get in Excel to a 3D chart. If you really want real 3D charts, you have to buy a program that does that kind of things. A program like MathLab or Excel Fit or whatever feature there is. But you can do some work in a more primitive way. Sorry about that. Excel was originally a financial application. It has gone pretty far in more general scientific issues, but it's still not the perfect tool for it. If you want to know more about Excel for Science, I developed a CD-ROM and a book that you can find at genesispc.com. It has 4 parts in the module and in the book, and one of them is plotting data, where I go into questions like, are there 3D charts, how do you handle axis issues, how do you handle bars and error bars, how do you do interpolation, how do you use formulas in graphs, etc. And there is also a lot of information on data analysis, curve fitting or regression analysis, and statistical analysis.